So you can see that, guys, there is normal light in the room, and this is the LDR over here, and this is our HC-05. It is sending data to this phone. See that the LDR over here is saying normal light. I place my hand on it. Now it says darkness. See, darkness. Now I remove the hand. It again says wait for the data. Normal light. Again the normal light. Light darkness. Now I place my hand little bit above. See, it says light darkness in the room. Because hand is little bit above, it means light darkness, and we had programmed it. Now I remove the hand. Again normal light. Now I turn on the flashlight. Now let's see what it says. See, it says very bright. See, again I place my hand on it. It says light darkness. Because light is falling, I press the hand. See, darkness. I had completely covered the LDR. Now I remove it little bit. Light darkness, I remove my hand. It says very bright. So that's it, guys. Hello guys, welcome to learning microcontrollers. In this video, I'm gonna show you how you can make a wireless darkness detection system using an LDR sensor and a HC-05 Bluetooth module. So let's get started. So guys, this is our PIC16F877A microcontroller having 40 pins. It's a DIP version. This is our HC-05 module. As you can see, it has 6 pins. The one next to the button is the enable pin. In some modules, it is also labeled as a key pin. When high you are in the command mode, at that time you can change the baud rate and other settings like password, name, etc. of your HC-05 module. But when it is connected to the ground or left floating, like you do not connect it to anything, then you are in the normal operation mode like data mode. Now you can connect it to the PIC or any microcontroller and do the task you want to do. Then guys, the above it is the VCC, then we have ground, then we have TX, RX and the state pin. So guys, as you can see, it has TX RX pin, so it's a UART module. So here what settings we are going to use is that the one I did in my previous video. I will share the link of that video in the description, in which I taught you how you can change the default settings of an HC-05 module using a CH340 USB to TTL device. So I will be using that setting that we did in that video. So guys, let's get started. Let's connect it to our PIC. To connect this to our PIC, we will need the UART port of the PIC, that is pin number 25 and 26, TX and RX. So let's connect it. Your RX pin of the HC-05 will go to the TX pin of the PIC, that is pin number 25 of the PIC. Then your TX pin of your HC-05 will go to the RX pin, that is pin number 26 of the PIC16F877A, like this. Now guys, for the ground connected to the ground of the PIC, for the VCC connected to the VCC of the PIC. The rest of the two PICs you do not have to connect. In this way, our HC-05 is connected to the PIC. Now guys, for the LDR, this is LDR, light dependent resistor, easily available in the market. It has 2 pins. You can shuffle these 2 pins, doesn't matter. So guys, I named the one pin as value, other pin as the 5 volt. You can shuffle these 2 pins, like you can name the upper one as 5 volt, lower one as the value. Now guys, what we do is that we connect it with the PIC. To connect this with the PIC, you will need a 10 kilo ohm resistor like this. Then you connect the value pin to the one end of the 10 kilo ohm resistor like this. Then guys, from the same pin, you will take out your output. You can use any ADC pin of the PIC. I am going to use the pin number A0 like this. Then guys, from the other end of this 10 kilo ohm resistor, send it to the common ground like this. Now guys, the other pin, that is the 5 volt pin, you connect it directly to the VCC pin of the PIC. In this way, our connections are completed. So our HC-05 is connected and our LDR is connected. Now we can make a darkness detection system. So let me introduce you to the hardware before we move on to the programming. So guys, this over here is our hardware. This is the LDR sensor and this is our HC-05 module, and this over there is a PIC16F877A, and this is the mobile phone at which the sensor will send the value using the HC-05 module. So we will be using this normal Android smartphone. So guys, let's get to the micro C for PIC. Let me zoom in so you guys can see better. So guys, as you can see, this is version 7.2.0. You can use the higher version as well. Higher is always better. So click on new project. This window pops up, new project wizard. Click on next, write the name of the project. I write LDR HC-05, HC-05 wireless sensor tutorial by learning microcontrollers, like this. Then guys, this is the path where you want to create the files. This is the microcontroller. I am going to use a PIC16F877A, and the crystal connected to the pin number 13 and 14 of the PIC16F877A. You entered that crystal's value over here. I have a 20 megahertz crystal there, so I will enter a 20 megahertz value here. Now click on next and finish. So guys, this window pops up. Before you do anything, first of all, save your work, press Ctrl S, save it. Now guys, first of all, go to the right. You have to select the libraries, expand the micro library, expand the system libraries. We will need the ADC library for our LDR, because LDR will send ADC output. So you click on it, go to this ADC INIT command, double click on it, and in the example here you have this command, copy it, paste it right next to the void main like this. Now guys, give some initialization delay. This is not necessary, but I always suggest you give it in the one time loop. So guys, this command over here will enable all the ADC pin of the PIC. Now you can use any ADC pin of the PIC after using this command. Now the next thing is, we have HC-05, which is a UART based module. So we will need to initialize the UART library. So check mark the UART library, then go to this command UART1INIT, double click on it, and in the example here you have this command here, copy it, paste it below it. Now guys, this is the syntax of the command over here, and this is the baud rate. The baud rate you will write down here is the one you had set in the command mode. By default, the HC-05 comes at 9600 baud rate, and I had not changed the baud rate, so my baud rate is also 9600. So you have to go to the command mode. I have a video on that, the previous video, so I will share the link of that video in the description. If you want to change the baud rate, you can do that as well, but by default it is 9600. So we will use the HC-05 at 9600, and now sub initialization delay. So we have our HC-05 initialized, we have our ADC pins initialized. Now guys, we can go for the forever loop. So write down while 1. Forever loop starts here, ends here, and inside it, first of all, we will need to read the value from the sensor. For that, we will need a variable which will store the value coming from the sensor. I take an integer variable, int LDR, I name it. Then guys, first of all, we read the value. I write LDR equals to ADC underscore read from channel 0. Now here guys, this is the syntax of the command, and 0 is the channel from which data is coming. If you have connected your sensor to some other ADC pin like to A1, A2, then you will write 1 here, and if it is connected to AN2, then you will write 2 here. I have connected to AN0, so my channel is 0 here. So whatever the value will come will go into this variable. It will be stored in this variable. Now guys, we will need to send this value over the UART to the HC-05, so it can transmit to the Bluetooth, and Bluetooth will send it to our mobile phone. But we cannot send integers directly, or it is not safe to send integers directly. We have to convert this to a string. For that purpose, we will need the conversion library. Go back, here you have this conversion library, check mark this. Here look for the command int to string, this command, integer to string. Now this command over here, copy it. This will convert this integer to a string which can be transmitted over the UART channel. Now guys, we will need another variable, a char variable, which will store the converted value, that is a string. I write LDR1, and maximum digits it can have is 6. 6 are enough. So that's all. Now guys, go back here, write down the integer whose value is to be converted, and in the next bar, in which the converted value in the form of string has to be stored like this. Give initialization delay, not necessary, but I always suggest you give it like this. Now guys, whatever is in this integer will be converted into a string and will be stored in this. Now we have to send this string over the UART channel. So now go to the UART library. Now this is the UART library. You have this command here, UART1 TX ideal. Now this command over here will check if the TX buffer is empty. Then it will allow you to send the data. If you don't use this command, still you can send the data, but the problem is the data can get distorted and you will get like empty spaces which you don't want, like this. Now inside it you will write this command, UART write text. Now here you have this command, UART1 write text, copy it, paste it here, or you can write it, and whatever you want to send, write inside this like this. Now UART1 write text is the syntax of the command, and LDR1 is the string we want to send. Now to make it look presentable, what I do is that I add some extra spaces so that the values don't mix up. So I add some space here and some space, that's all. Now guys, what I do is that I give some delay as well, else the values will come too fast, they will become difficult to read. So okay, we leave the delay, let it be as fast as possible, no issue with that. So this is our code, let's build it. Okay, it's built, no errors. Let's burn it. Go to your PIC16 programmer tool, select the microcontroller, go to the file, import hex file. This is the file, click on write. Okay, the new file is being written. Let it write. Okay, let it write the new file. Okay, it's written. We power up the circuit from the PIC16 programmer tool. I click on. Okay, our circuit is on. You can see that HC-05 is blinking very fast. Now, what we do is that we go to our phone. I log in and install any Bluetooth app in the Play Store. So I had installed this one, Bluetooth terminal. So let me show you how to install it again. In case you don't know how to install it, I uninstall this. Just go to the Play Store over here, and in the Play Store write HC-05 over here. HC-05, write it down like this. And there are various apps. You can use any app, they all do the same. I will download this one, it's the top one. Click on install. Okay, let it install, it's installing. Okay, it's installed. Click on enable. Now open it. Go to the left here in the devices. Now give it the required permissions by first of all turn on the Bluetooth. Now go to this Bluetooth setting. Here you have the device. My device name is learning microcontrollers. I had already entered the password, so it's there. Go to the setting, connect it. Okay, it's connected. Now go back to the app. Now what you have to do is that refresh, so you can give the permission for the first one, allow. Now see that learning microcontroller is available. This is my HC-05 module over here. Now see that the blinking speed of the HC-05, it is blinking very fast, but once it's connected it will slow down. So I touched it, now it shows connected. Now see, we are getting values from the LDR. See that the sensor is connected. See, we are getting random values, like what we are getting here is 525, 530, 528. Now I will place my hand on LDR. So see, the value drops. Whenever, it means the light intensity has lowered down. I remove my finger. See, again it goes high. I place it. Again it drops. Now I make the light very high. I use a cell phone's light. See. Now see the value. Value has gone above 840 because the value is now very high. See, I place my hand. Now the values go down like 250, 260. I remove my hand. Again they are like 840, 850. I place my hand. Again the value fall. So we can, let me turn on the flashlight. Turn off the flashlight. Now see that by default light in the room, LDR value is like 520. So we can say that above 400 and below 6, okay, above 500 and below 600 it's normal light, and above 800 it's very bright, and below 400 it's dark. So let's do this. We have our calibration values. Now we go to our coding again. Let me zoom in. So what I do is that now instead of sending the just these values, I will send the strings which will represent like it's either it's dark or its brightness in the room. Now what I do is that here instead of sending these, what I do is that I will use if, okay, use it here, if LDR is greater than 500 and LDR value is less than 600, then it's normal light in the room, double bracket. Now this is the condition, this is our normal state. So what should happen if this is the scenario? Then it will convert the LDR value into string, and over the LDR channel it will send this value like this here. Now what value it should send is, instead of sending LDR, it will simply write after some space, it will give some space, and then instead of sending the LDR value, it will write normal light. See, it will only display a normal light again and again on the screen like this. Now this is our one condition. Now in case else if LDR is less than 500, then we call it dark. Now again copy all this inside it, place it here, and again the LDR value will be converted to LDR1 and it will say darkness, or we call it light darkness. It's light darkness in the room, not very dark. If it is less than 500 and, or we call it like it is greater than 200, okay, we make it a better condition, greater than 200. I will give you the hex file and all these micro-C files in the link of a Google Drive in the description, so you can play with the code, no issue with that, so don't worry. So if it is greater than 200 and LDR is less than 500, then it's light darkness, not too dark, it's light darkness. And then else if, now again copy this, you can make as many conditions as you want. If it is less than 200, then remove the other condition. If it is less than 200, then it will say it's darkness, it's very dark in the room. So we don't need to convert the integer to string anymore like this, you just delete this, we only send the strings, not the value anymore. So if you want to send the value, you can send it, but there is no need to send the value. See that? Now if the value is below 200, it will send darkness. Now the final condition, I think I had removed the bracket here, so it's now copy it again, paste it here, also remove these, we no longer need this, I only use this for copy pasting. Now if the value is above, like what is our highest here, normal light is still 600, if it is greater than 600, then it is, we call it very bright light like this. See, now these are the condition. Now here check the brackets, they are perfect here. Okay, now build the code, check for errors, no error, that's perfect. Now go to the PIC16 programmer tool, where it is, okay, here, click on write, the code is already selected. Okay, the new code is being written, let's go back and see what happens. This time what is going to happen is that, as per our expectation, if there is light between 500 and 600, then it will show that there is normal light in the room. If the light in the room is above 200, less than 500, then it will say light darkness. If it is below 200, it will say very darkness. If it is above 600, then it will say very bright light. So that's simple as that. Let me zoom out and let's get to the hardware. So this is the hardware. See, HC-05 is blinking slowly, very slowly, you can see that. It means that it is already connected, it auto connects to the last known device. So we never basically disconnected it. Now see that what we are getting here. It is showing light darkness. Now it says normal light, normal light. Now I place my hand on it. See, it shows darkness because I have a finger on it. See, darkness. I remove my hand. Now again it says normal light. See, because this is the normal light in the room. Now I place my hand. Again it is darkness. Now I will move the hand little bit above it. See, it says light darkness. So it is working perfectly. See, light dark. Now I remove my hand. Now it says normal light. Now what I do is that I turn on the flash. Now what it should say is very bright. See, it says very bright. So that is it, guys. That's how you can make a wireless sensor system using LDR or any other sensor using ADC pins. So I hope you guys learned something from this video. I will share all of these micro C4 PIC files and hex files, all the set that comes with the build in a Google Drive link in the description of this video, so you can play with the code. So if you have any questions, you can ask in the comments. So thank you very much for your time, guys. We'll see you in the next video. Goodbye.